Hello, my name is Hideo Nagahashi. Then I want to talk about how to find the sums. So let's look at some examples. Okay. Well, finding sum looks like an easy job. Okay. So for example, so what is the sum of 1, 2, 3, 4, and 5? Then of course you know, you can just add one by one. So 1 plus 2 is 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, so that's 15. So the sum of these numbers are just 15. Okay? So of course there's nothing wrong with doing this, but I want to introduce a very interesting way, okay, to find this kind of sum. The idea is so you just call this S to be the sum. So I want to find the value of S. Okay. To do this, I just rearrange this S from the bigger one to the smaller one. Okay. Then I add these two term by term. So S plus S is of course just 2S. Now, for each term, you get 1 plus 5 is 6, and here also 6, 6, 6, and 6. So you just have 5 6's here. So of course this is 6 times 5, which is 30. So you get 2 times S is equal to 30. Then, so of course you can just get S by dividing by 2. So it's 15. Okay? Then, well, of course, as we expect, so we have already seen that the sum is 15. So then why this is good? Well, so if you just add 5, so of course there's no difference, but this method is better in a sense because just imagine you want to add 100 terms instead. Then, of course, if you take time, you can just add one by one, but this takes longer. Okay? But if you use this idea, then it's much faster. So what you do the same thing. So you just write down from the bigger one. Okay? Then add term by term. S plus S, again this is 2S. Now each sum is again the same. Each term is always not 101. How many? So that's, you can count just 5, but of course this is just the 1 to 100, right? So that's why you have 100 of that. Okay? So you have 2S is equal to 101 times 100, so which is 10,100. So by dividing by 2, you can now easily get the answer to be just 5,050, which is much faster than adding one by one. So that's why that's advantage for so using this method. Now let's look at another example. Instead, what happens if you have one plus 2 plus 4 plus 8 plus 16? This time, the previous method does not work. Let's try. Okay? So again, you just write down from the bigger one. But 2s is equal to, this is 17, 10, 8, 10, and 17. So the whole point for the new method is if they're same. So you can use multiplication to easily get the sum. But adding these 5 is as hard as adding this. So that's why it doesn't make, you don't get any progress here. So that's why this idea is no good. The point is, for the previous one, why do you get the same thing? Because the next one always just increased by the same number, right? So this is called arithmetic, the series. Or in a sense, so this is really the same idea behind this is a linear function here. But this one, instead, now the next one you can get it by multiplying by 2 here. Okay? So they just formed by the different idea. Okay? So that's why this doesn't work. But instead, so you have a better method now. Okay? The new method is just using this idea. What you can do is, since the next one always obtained by the multiplying by 2. So what you do is, instead of rearranging, you multiply each term by 2. Okay? So 1 times 2 is 2. I just write it here. Okay? 2 times 2, which is 4, I write 4 here. Then 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. Okay? Why did I write? Why did I shift? What I want to do is now subtract term by term. Yeah. Since I just shifted right, so they are all the same. So in other words, if you subtract term by term, all the middle terms are cancelled out. So you only have 0 minus 1, which is negative 1. 2s minus s is, by the way. So that's just s. And that's all 0. It's all gone. Then you just have 32. Okay? So in other words, s is equal to just 32 minus 1, which is 31. Okay? Then, of course, you can easily check this is correct by just adding 1 by 1. But again, this is only 5, so it doesn't make much difference. But just imagine you want to add like 100 terms of that. So this method is much easier because you only need to just compute just the head and tail. Okay? Thank you.